Hey, I'm Hussein. Here's my student ID, and I'm presenting Project 2B, Light Intensity Controlled Pulse. Alright, first of all, my primary and secondary functions. The primary function of the circuit is to blink the LED right here. I have two secondary functions. First one is seeing how varying the internal resistance on this potentiometer might affect the blinking speed. And second, I want to see, like, this circuit can be implemented in a toy gun because of the clicking noises produced by the switch inside, the relay, and the rapid flashing, which is similar to a gun being shot. Okay, so now explaining the circuit, we have two loops. First one is power supply, potentiometer, 1000 microfarad capacitor, and our relay. And second is power supply, relay again, photoresistor, 330 ohm resistor, and our LED. Alright, so what happens is current is fed to the resistor. This charges up the potentiometer charges up the capacitor. Once it's sufficiently charged, the switch inside the relay is triggered. So now power is flowing to the second loop. Basically, photoresistor detects lights. If light is up, then resistance goes down, allowing more current flow to the LED, which causes it to shine brighter. If light is low, then resistance goes up and less current is flowing to the LED, and it shines a bit more dimmer. Alright, so now it's what happens, like, why is it blinking instead of shining, is because the capacitor can only hold the charge for a few milliseconds before the switch is triggered. Alright, so the back and forth triggering between loop 1 and 2. First of all, we're charging up this capacitor and allowing the trigger to flip. And second, we're turning on the LED. So the switching, rapid switching, because of the charge and discharge of the capacitor, is what causes the blinking. Alright, now I'm going to show you the circuit in action. Alright, so as you can see, the LED is shining brightly, blinking brightly, because there's a lot of light in the room, and the internal resistance of the photoresistor is going down. Now if I turn off the light, the blinking is still at the same speed, obviously, but now the intensity is much less because the photoresistor here, here is capturing much less light, and the current that's allowed to flow into the LED is much lower. So now I'm just gonna go turn on the lights again, and quickly we see how the LED is shining brighter. Now I want to demonstrate my secondary function, which is to see how changing the resistance inside the potentiometer might affect the blinking. Not the intensity of light, but rather the blinking speed. Alright, so I suspect from theory that tau equals RC, charging time. If resistance goes up, then charging time goes up as well. Indeed, if I increase the resistance, then blinking stops, because now stops, or even if I reduce it a bit, it slows down dramatically. That's because the capacitor is charging super slow now compared to before, so the switch is barely triggered at all, right? And conversely, if I go the other way, then now it's charging super fast, the switch is triggering super fast back and forth, and this blinking is much faster. So we're not affecting the intensity of the shining, but rather the speed of blinking back and forth. So now for some measurements, I'm bringing my DMM. First of all, voltage, power supply. I don't know if you can see this. We're having about 5.665 volts instead of 9 volts, so that's definitely changing the values. Next, voltage on the photoresistor that's feeding the LED is 2.4 volts. That's much higher than what I calculated, but I suspect the reason is that the photoresistor has varying internal resistance, whereas in my calculations in LT Spice I used a constant 100 ohms. That's because I could not simulate a potentiometer on LT Spice. But I did take, in theory, I did take different values and see how that affects. And on my capacitor, I'm getting 1.6 or 1.7 volts. That's also higher than what I calculated, but this is obviously because the potentiometer has been tampered with instead of being at a constant 120 ohms as in the theory and LT Spice. So we've demonstrated our different primary and secondary functions, and we've taken some measurements. Thanks for watching.